Hi, my name is Dhruv Gupta from Team 13380, the Quantum Singers, and today I'm going to be talking about robot vision and more specifically Euphoria with you guys. Now, firstly, let's talk about where and when robot vision is used in FTC. Every season, there'll be a specific challenge in Autonomous where you'll have to detect something, whether that be a duck, like this year, also your team capstone this year, or in the example here from Robotics, we had to detect this Yellowstone and which position it was on. It could have been either on the left, the center, or the right. A couple years ago in Skystone, we had to detect a stone with a special image on it, things like that. Every year, you'll have one of those autonomous challenges. Vision technologies such as Euphoria and TensorFlow and OpenCV can help you with detecting that. The other place they're used are with these navigation targets. These navigation targets over here, there's usually four on each field, can be used to help situate yourself on the field during autonomous and during teleo. Now let's discuss the different vision technologies. The four main ones are Euphoria, TensorFlow, OpenCV, and DogeCV, though there are more. We will only cover Euphoria during this presentation, but all of the others work in a very similar manner and their programming is also quite similar. So this should give you the basic knowledge you need to work with any of them. The FTC SDK usually has an example program using TensorFlow and Euphoria for that year's Autonomous Vision Challenge. So we're going to show the year's code example location in just a second. Usually what teams do is copy this file to their team folder and modify according to their requirements. We'll walk through an example code of an autonomous program which uses Euphoria later on in this presentation. So first, let's go ahead and go to our team's SDK. Now, if you go into FTC Robot Controller and look at the external examples, along with all of these other concepts, you'll see concept TensorFlow, object detection, switchable cameras, concept TensorFlow object detection, concept TensorFlow object detection webcam. Same with Euphoria, you'll have all of those. And what we're going to do is look at concept Euphoria ultimate goal navigation. And here we are. Now, if we start from the top, they go ahead and give you kind of an introduction to what Euphoria is and how they expect this to be used. It's always good to go ahead and give this a read when you do choose to implement either Euphoria or TensorFlow, just so you have all the information. And now when we get into the actual bulk of the program, there'll be a couple of things that you have to specify yourself depending on how you're running it. Now, Concept Euphoria Ultimate Goal Navigation is meant to work with a phone. There's also Concept Euphoria Ultimate Goal Navigation Webcam. So all these specifications will be different depending on what you use. In the phone program, for example, you have to specify camera choice, whether you're using the back phone or whether you're using the front phone. You have to specify whether your phone is in portrait or in landscape, etc. So these are all things that you'll do based on your own robot. The next thing you'll have to do is provide your Euphoria key. And we're going to talk about what Euphoria keys are and how you can obtain one in just a second. Now, if we go a little further down into our program, we see public void runoff mode. They take some of the information, which we specified a little earlier, and then we go further down. We will see the GL matrix. Now, one of the really cool things about Euphoria and these other vision technologies is that they don't just tell you whether an object has been detected. For example, one second, let me just refresh this because sometimes it gets stalled. They won't just tell you that there's a yellow cube detected on the left position, or there's a yellow cube detected on the center position. They'll tell you about your orientation in respect to that cube. So it'll tell you, oh, you're 13 degrees or negative 13 degrees in respect to this cube. You're 16 inches forward and 7 inches to the right and 3 inches above, for example. And this is all determined based upon the position of your camera. And they use OpenGL matrix to do so. So now let's go ahead and talk a little bit more about the different about Euphoria and getting a license key for the team. So Euphoria, as we covered before, is a program that can detect the vision target location with respect to your robot. And to use Euphoria, you need to get a Euphoria license key. To do that, you create a login at the Euphoria Developer License Manager, and you follow the instructions from there to get a key. Now, if we navigate to the License Manager here, you'll see this is the page which we specified right here. You have choices such as register and login, depending on whether or not you have an account. If you register and follow the process, then you'll be able to get yourself a key. We'll talk in just a second. You'll see an actual example key, and you'll see how it's used in a program. But first, let's just walk through an example of a season where you needed Euphoria and where my team specifically used Euphoria, so we can explain to you a little bit more about its features and its usefulness. And then we're also going to go ahead and walk through the program, which is associated with the video I'm going to show you. Now first, we're just going to wash through up until 30 seconds once, and then we'll go back through and I'll sort of explain what's going on and some of the places where Euphoria comes in really handy. So let me just make sure I'm sharing computer sound. All right, and we should be good to go.
Good job, come on. Come on, Alicia. Let's go.
All right, so let's go ahead and discuss what the challenge is. Now, as you can see here, there is a row of 6 of these blocks. 2 of these blocks have these special targets on them. If you pick up the block with the target and transport it to the opposite side, you will get extra points as compared to if you just pick up a normal block and transport it to the other side, which is why teams wanted to transport both of these target blocks to this blue side. Now, what our team is doing is going in front of each block one by one, detecting it and seeing whether or not it has the target on it. If it does have the target on it, we go ahead and move forward, grab it, rotate, and take it to the other side.
Good job, come on. Come on, Alicia.
Now, as you can see, the first thing we did was look at this first block. We saw that it wasn't a target, so we moved to the right a little, looked at the second block, and we found that it was a target. So it worked out, we picked it up, and we took it to the other side. Now, one other thing that I wanted you to take note of is if we go right here, watch this interaction between our robot and the other robot. And you'll see that we actually hit each other a little, and that causes our robot to turn. So right there, if you saw, we kind of pushed forward into their robot, which caused us to turn a little and them to move a little backwards.
Come on. Alicia.
And now this is one of the places where you can really notice how helpful vision technologies such as Vuforia and TensorFlow are. If we'd been using an arbitrary distance, like let's say we detect the target and then we always just move 12 inches forward, try and grab it, and then move 10 inches back, turn 90 degrees and go forward, we would not have been successful because our interaction with this robot pushed us maybe like 5 to 10 degrees to the left, and then we went back around 8 feet. So that distance really like exacerbated um, that turn. So now we're in like a very unideal position as to what we would have programmed it to. We would have expected it to be maybe 4 or 5 more inches to the right, and we would have expected our robot to be perfectly straight. But as you can see after this turn, the robot is curved to the left. Now here's where Vuforia comes in really useful. When it detects the target, it tells us that, oh, you are 12 degrees to the left of the target, you're 17 inches, the target is 17 inches in front of you, and the target is 3 inches to the right of you. And what this allows us to do is correct ourselves, as you'll see right there. We turned the distance that Vuforia told us we were off, and by doing that, we were able to get straight on to the target and we're able to pick it up successfully. So this is one of the places where Vuforia is really, really useful. Now let's go ahead and take a look at the program which we use, which we ran right here in this round. Now here it is, loading red. As we mentioned earlier, when using Vuforia, a good practice is to just make a copy of the concept file presented to you in external samples and then place it within your own team code. So as you can see, like the first types of things in this file were right here, your Vuforia localizer.camera direction and your final Boolean phone is portrait. We have those same things here. We have tweaked around with some of the other things just to make it a little more clear for all of you here, but here. Now, the first thing that I want you guys to check out here is our Vuforia key. Vuforia keys are very long, but you need to define them here for you to be able to use the vision technology. Now, if we go down here a little, the next thing we did was define a variable called location. Now, location is an array with 7 values. The first value is represents whether or not we detected the target. So in most cases, this will be 0. If we detect the target, it'll become 1. Then these next 3 represent the distance to the target. This one represents how many inches forward the target is in relation to us, how many inches to the left the target is in relation to us, and how many inches lower the target is, or how much higher we are in relation to the target. These 3 similarly represent our degree measure in relation to the target. And now here are just some more example variables that we use in our programming, but which aren't relevant to Vuforia. Now here is our, this is one of our functions. It's called detect once. Detect once is just uses, it just detects, it sets target visible, which is like what we use to see whether or not we've detected to false at first. Then it checks through Vuforia. If Vuforia sees the target, if dot is visible is true, then it sets target visible to true. And now if we find that target visible is true, then what we do is like adjust our position to be in an optimal place to pick up the target, to pick up the stone with the target. And we go ahead and call move to skystone, which move to skystone moves forward. First it adjusts and then moves forward based upon whatever we picked up in location. So as you guys remember, location is this array here, which stores all of our values in relation to the skystone. Now, when we get into run op mode, when we're actually running it, if we go a little further down, we'll see the movement. We do target skystone.activate, and then we come in and we do detect once. From here, this is all kind of like just our programming, which is detecting. If detect once gives us a false, then we move to the right and try detecting again, etc., etc. Once detect once is true, then we move forward. We pick up our skystone. We move back. We turn left. We drop it off, and then we come back and try and find the second one. So this is basically how Euphoria works in a program and some of the special things you can do with it. Again, probably the most useful features of it is the fact that it gives you all of the distances in relation to the skystone or whatever you are detecting, which is really useful. Now, as we mentioned earlier, there are many other systems as well. For example, you've got TensorFlow, OpenCV, DodeCV. Each of these has their own advantages and disadvantages, and there's a lot of information readily available about them. Using them is all very similar to what we've done in this presentation, and thank you for listening.